Hello students, so welcome to the lecture series on previous year gate questions of electronics and communication on the topic of two-port network. So let's come to the questions directly. So here we have to find the H parameters of the circuit, and circuit is given to us, that is 10 ohms and the 20 ohms circuit. I1, I2, and this is V2 and this is V1. Okay. Now we can easily see that the current in 20 ohm resistance will be I1 plus I2. Okay. So V1 is equals to 10 I1 plus 20 I1 plus I2, and V2 is equals to 20 times of I1 plus I2. So V1 is equals to 30 I1 plus 20 I2, and V2 equals to 20 I1 plus 20 I2. Now in H parameters we find I1 I2 in terms of V1 I2 in terms of I1 V2. So this is equation number 1, this is equation number 2. Using equation number 2, we can see that I2 is equals to V2 minus 20 I1 divided by 20, that is V2 upon 20 minus I1 is equals to I2. This is equation number 3. Okay. Now using equation number 1 and 3, I can say that V1 is equals to 30 I1 plus 20 I2. So I2, I will be putting equation number 3 in place of I2. So I will get V2 upon 20 minus I1. So that is 10 I1 plus V2 is equals to V1. So this is equation number 4. Now using 3 and 4, I can say that V1 I2 is equal to minus 1, 1 upon 20, 10, sorry. So 10, 1 using equation number 4, and using equation number 3, it is minus 1, 1 upon 20, I1, V2. So this is your H matrix. Now if I compare, then it is 10, 1, minus 1 and 0.5. So D is the correct answer to the question. Now let's move on to the next question. So here we have this circuit. We have to find the Z11 and Z12 of the circuit. So we have the circuit 2 ohm resistance, 1 ohm resistance, 2 ohm resistance, 1 ohm resistance, and 3 ohm resistance. Okay. Now the best possible solution to the question is to convert this pi network into a T network. Okay. So we will convert this into a T network. So let us say that there are 3 resistances. This is one resistance, this is resistance number 2, and this is resistance number 3. So it is R1, R2, and R3. Okay. Now it is, so let me draw it in a similar format that we used to study, that is, this is your delta and we are converting into a star. that is R1, R2 and R3. This resistance value is 1. Okay, so R1 is equal to 1 into 2 divided by 1 plus 2 plus 1, that is 2 by 4, that is 1 by 2. Similarly, R2 is equal to 1 into 1 divided by 4, that is 1 by 4, and R3 is equal to 1 into 2 divided by 4, that is 1 by 2. Now the circuit can be redrawn as 2 ohm resistance. Here it will be R1, that is 1 by 2. Here it will be R2, that is 1 by 4. It will be R3, that is 1 by 2. Then 3 ohm resistance, and this is the 2-port network. V1, V2, I1, I2. Okay, so V1 is equals to 2 plus 1 by 2 into I1 plus 1 by 4 into I1 plus I2, because here current is I1, here current is I2. The current in this resistance will be I1 plus I2. So applying KVL in this loop, we will get V1 is equal to this. So V1 is equal to 2.5 I1 plus 0.25 I1, 0.25 I2, that is 2.75 I1, 0.25 I2. So from here we can see that this is Z11 and this is Z12. So Z11 is 2.75 and Z12 is 0.25 ohms. So Z11 is 2.75 and Z12 is 0.25. So A is the correct option to the question. Now this is a very good question. Here first of all read the question. This is the lattice circuit given to us and we have to find the Z matrix of the circuit. Okay, so now first of all let's solve the circuit. Okay, so first of all let me copy the figure. So let me paste the figure. Now first of all we will find the Z matrix of the circuit itself. So this is V1 voltage, this is V2, here current is I1, current is I2, current will be I1 and current will be I2. Okay, so let us assume that at this node current in this branch is capital I. So current here will be I1 minus I. Okay, now at this node I1 minus I is entering and I2 is also entering from the right side. So current in this branch will be I1 plus I2 minus capital I. Now at this node, since I1 goes out, so in this branch the current will be I2 minus I. Now since I is coming here and I2 minus I is coming here, so I will go out. Okay, so KCL is satisfied at all the nodes. So this is node A, this is B, this is C, this is D. Okay, now let us solve the KVL loop A, B, C, D, A. Okay, so from A to B, I can see that since the drop will be plus at the left side and minus on the right side, and the current is and the motion is from A to B, so there will be a plus sign ZB into I1 minus capital I. Now from B to C, since the current is also flowing from B to C, so the drop will be plus ZA into I1 plus I2 minus capital I. Now from C to D, since the current is also from C to D, so it is plus ZB into I2 minus capital I. And last from D to A, since current is from A to D, so we are entering from the minus terminal, so there will be a minus sign here. ZA into the current, that is I, is equals to 0. Okay, so ZB into I1 minus ZB into I plus ZA I1 ZA I2 ZA I plus ZB I2 ZB I ZA I is equals to 0. Now let us take I as common. So what all are the terms here? So these four are the terms, that is minus 2ZA minus 2ZB I1. So there are two terms, this term and this term, ZA plus ZB plus I2. There are two terms, ZA and ZB. So ZA plus ZB is equals to 0. So I is equals to I1 plus I2 divided by 2 is the conclusion. Okay, from the above KVL loop. Now let me paste the figure again. So this is V1. I1 is the current here. I2 is the current here. Now current in this loop was I. Current here was I1 minus I. Current in this branch was I1 plus I2 minus I. Okay, this was A, this was B, this was C, this was D. Now applying the KVL loop in this loop. Okay, now A, B, C, A is a KVL loop. Now A to B plus minus drop, that is ZB into I1 minus I. Now B to C, the drop is from B to C, that is ZA into I1 plus I2 minus I minus V1 is equals to 0, because from C to A I am entering at the negative terminal. So V1 is equals to ZB into I1 minus I ZA into I1 plus I2 minus I. Now we know that I is equals to I1 plus I2 divided by 2. So V1 is equals to ZB into I1 minus I1 plus I2 divided by 2 plus ZA into I1 plus I2 divided by 2. Okay, I'm just putting the value of I1 here. I will get this. Now this is equal to ZB into I1 minus I2 divided by 2 I1 plus I2 divided by. So taking I1 as common, I will get ZA plus ZB divided by 2. Taking I2 as common, I will get ZA minus ZB divided by 2 is equals to V1. So this is equation number 1. Okay, now I will paste the figure again. Okay, I will paste this figure. Now let me complete the, okay, I will just copy the figure. Okay, now at this node, since I1 will go out, so the current in this branch will be I2 minus I. Now the voltage here is V2. So we will apply the KVL loop. So which color should I choose? Let me choose pink. Okay, so this is the loop. Okay, so from B2, so the KVL loop is BC DB. Okay, now B to C, the drop is plus to minus, so it is plus ZA I1 plus I2 minus I, plus minus again C to D, ZB into I2 minus I, D to C we are entering at the minus terminal, so minus V2 is equals to 0. So V2 is equals to ZA, putting the value of I here, we will get I1 plus I2 divided by 2 ZB into I2 minus, okay, so we will get ZA into I1 plus I2 divided by 2 ZB into, so this will give me, taking I1 as common, ZA minus ZB divided by 2, taking I2 as common, ZA plus ZB divided by 2 is equals to V2. This is equation number 2. So from equation 1 and equation 2, the Z matrix is equal to, of the lattice circuit is equal to ZA plus ZB divided by 2 is Z11, ZA minus ZB divided by 2 is Z12, Z21 is ZA minus ZB divided by 2, and Z22 is ZA plus ZB divided by 2. So this is the Z matrix of the lattice circuit. So this is the whole method, and you can learn the method and you can learn the result also. And one very important thing is, since Z11 is equals to Z22, so lattice circuit are always symmetric, and since Z12 is equals to Z21, so lattice are always reciprocal. Okay, now in the question, let's go to the question directly. Since ZA and ZB are given to us, so since ZA is equal to, so let me check again, I forgot the values. So Z is equals to 2J and ZB is equals to 2. Is equals to 2J and ZB is equals to 2. So Z matrix will be equal to ZA plus ZB divided by 2, that is 1 plus J, ZA minus ZB. Okay, so J minus 1, again J minus 1, and last one is 1 plus J. So this is the result, and we can easily compare and we can get that the answer to this question will be D is the correct answer. Okay, 1 plus J and J minus 1. So let me check, 1 plus J and J minus 1. So D is the correct answer to the question. So here we finishes the part 7 of the lecture series. We will be continuing the questions in next part of the lecture series. So thank you guys. Keep following the lectures and keep sharing them. Give us your feedback and subscribe to the channel. Thank you.